Hey fellas, so section 3, we're still working with surface area, but now we're going to work with pyramids and cones. Pyramids are very much similar to prisms. Cones are very, very similar to cylinders. So that's good. We have a good start from 12.2. And I think the hardest part about this is just getting the terms together and the different parts of these things together. So make sure you take really good notes and try to draw really good pictures for them. So a pyramid is a polyhedron, again, three-dimensional polygon. Okay, it's a solid where the base is a polygon and all the lateral faces meet at one point, or a vertex, right? You know what a pyramid looks like. It's going to look like it's going to have some type of base, right? I'll draw a square one or a rectangular one, right? And then there's one point up top that connect to all of those vertices. And we have a pyramid. Okay, that's pretty darn good. Okay, so with that pyramid, I think you can visualize it in your head. Now, practice drawing it, okay? Make sure you can do that. And from that, we have to understand some of the different parts of it. Okay, so a base edge is going to be the intersection of a base and a lateral face. So this would be an example of a base edge. Okay, so if I say a base edge is a certain length, you know that's what I'm talking about. Any of those four sides would be a base edge. Okay, the height is the vertical distance between the base and the vertex. So this straight down, intersecting in the base at a perpendicular. Okay. The next one is a lateral edge. Okay, lateral edge is the intersection of any two faces. So for example, this right here, it's a lateral edge. And lastly, the slant height. All right, the slant height is the altitude of one of the lateral faces. So what it's going to do is it's going to cut this triangle in half, and it ends up being perpendicular right there. So as you can see, we can draw a whole bunch of right triangles out of this. With the altitude and the slant height, and halfway across the base edge, you could draw a right triangle there. Halfway across the base edge with the slant height and the lateral edge right here. Okay, there's another right triangle. All right, so there's lots of right triangles. That's what we're going to need to do to work with pyramids. All right, now the theorem to find the surface area of a regular pyramid is like this. Okay, so the surface area, S is surface area. I don't need to write it again. It's right there. Surface area equals the area of the base okay, because it's just one base this time, so it's just the area of the base times one, or plus 1/2 the perimeter of the base times cursive L, script L, is the slant height. Okay, so that gives us the surface area of a regular pyramid. Okay, and a cone is very similar to a circle, or to a pyramid, but has a circle as the base. Okay, so you have a circle as the base, point up at the top, and connect to the sides to draw it all around. Okay, it's like a party hat. Okay, so that party hat, you're still going to have a couple of similar terms. Okay, now we're going to have a radius. R is the radius. And the slant height, well, the height is still going to be just the vertical distance there. Okay, that's the height. And the slant height is going to be this on the side. Okay, so that's the slant height. Okay, so the surface area formula here, surface area equals the area of the base actually, let me rewrite this. Okay, so the area of the base plus 1/2 times the circumference times the slant height. Right, well, we're going to rewrite this again. Okay, just like we did with the cones. Okay, so the surface area, the better way to do this, we know the area of the base is a circle, so that's pi r squared plus 1/2. Okay, circumference of a circle, circumference of the base, okay, is 2 pi r times the slant height, cursive L. Okay, so we can do this 1/2 times 2. 1/2 times 2 is just 1, so those can go away. So the surface area is just pi r squared plus pi r L. Okay, where L is the slant height. And, oh, sorry, that should be pi r squared. And r is the radius. And we already talked about how S is the surface area. Okay, that's it for those. So some examples here, we're going to find the area of each lateral face. Okay, so the lateral area, just the lateral area of a regular square pyramid. So you draw a square as the base, put a point up top, connect to all the vertices, and there's my square pyramid. Okay, so you know the bottom's a square. We have base edge 10, which means all the base edges are going to be 10. Okay, and the two in the back are also on 10, and a height of 12. So that height is 12. Okay, height, remember, is the vertical one, straight down to the center. Like I said, right triangles are going to be really important in doing this because we're going to use this surface area equation, B. Well, I guess I don't need B. We have B plus 1/2 PL. Okay? Well, we don't need the B part because I'm not looking for the whole surface area. I'm just looking for the area of each lateral face. So the B part's not helpful to us. Okay? So the lateral area is just without the B. So 1/2 PL. Okay, so that's going to give us all four of them. I want each lateral face, so I can just get this answer and then divide by 4. Okay, so the thing that I really need, I already know the perimeter is 10 times 4, which is 40. Okay, I need the slant height. So in order to get L, I'm going to draw that right triangle right there. Okay, that right triangle is going to help me out. So if 12 is the height, well, this right here, this blue line at the bottom, is going to be half the base edge. So that's going to be 10 divided by 2. It's 5. Okay, so I could find this third one with the Pythagorean theorem. And you could do 12 squared plus 5 squared, which is 169. The square root of that is 13. Okay, I used Pythagorean theorem for that. Okay, so the slant height's 13, which tells us that we've got 20 times 13. So the lateral area is 260. Okay, but we want the area of each face, so we have to divide that by 4. So each face has an area of 65 square centimeters. Okay, now that, what we just found, is just the area of one of these lateral faces, one of these triangles. Okay, works just like that. So numbers 2 and 3 are really, really tough. Tough to draw and tough to actually work out because your base could be difficult shapes. This one, it's a hexagon. So we have a regular hexagon. So I have to draw a hexagon laying on its face. 2, 3, 4, 5, 6 sides. Okay, so you see my hexagon, point up top, connect all the vertices, and there's my pyramid. Okay, looks a little bit off, but you get the idea. So we have the base edge is 4. It's a regular one, so all of these are 4. And a slant height. Okay, remember, slant height goes right down one of those faces. That slant height is 9. Okay, so we need to find the surface area is B plus 1/2 PL. Well, we already have the P, right? The P is just 6 times 4, and the L is the slant height, which they told us was 9. So that's good, but we need the area of the base. So in order to find the area of the base, we need to find the area of a hexagon, okay, which can be difficult. All right, side length is 4. We need the apothem, okay? So we should be able to cut this up into a 30, 60, 90 triangle and see that the apothem is 2 root 3. If you need help with that, obviously go back to 11.2. That's where I did all of these problems, okay? So the surface area is 1/2. The area of the base is 1/2 ANS. The apothem is 2 root 3. Number of sides is 6. Side length is 4 plus 1/2. The perimeter is 6 times 4, which is 24, times the slant height, which they gave us, was 9. Okay, so now we have to just multiply all that out. So the surface area is 24 root 3 from this first one, plus 12 times 9 is 108, and square feet. Okay, number 3, like I said, another difficult one. All right, it's regular pentagonal pyramid, which means that the base is a pentagon. So 1, 2, 3, 4, 5 sides. Draw the lines to all the vertices. That's not bad. Okay. Luckily for this one, they give us a whole bunch of information. So we have the sides of the base has sides 18. So remember, it's regular, so all of them are 18. The apothem of the base, okay, right there, is 12.4. And the slant height, right there, is 24. Find the surface area of the pyramid. So we need S equals B plus 1/2 PL. Luckily, they literally give us everything. All right, the area of a pentagon, remember, is 1/2 ANS. Okay, so S equals 1/2. The apothem is 12.4. The number of sides is 5. Side length is 18. Plus the perimeter is 5 times the side length of 18. Right? 5 times 18. 18 plus 18, 5 times is 90. Times the slant height of 24. Okay, so once you get that, you can just do all the multiplication and addition in your calculator, like I'm doing currently. We've got 0.5 times 12.4 times 5 times 18. It's 558 plus 90 times 24 is 2,718 square inches. Square inches. Okay. Now the last two are not nearly as difficult as that one. Okay, so we just got cones. Cones are a little bit simpler. Okay, draw the circle. Finish it up. That's not very straight, but you get the idea. We've got the radius is 5. Slant height is 8. Remember, the surface area here is pi r squared plus pi r l. Okay, well, we already have the radius and the slant height, so we've got pi times 3 squared plus pi times 3 times 8. Okay, so we have 9 pi plus 24 pi is 33 pi square inches. That's the surface area. And last problem, find the surface area of a right cone. Okay, we still have a cone, just like that. We've got a height of 4√7 and a radius of 12. Okay, so we have the height, and we need the slant height. Pi r squared plus pi r l. We've got the radius, we need the slant height. So that creates a right triangle. So we just have to do 4√7 squared plus 12 squared. 4√7 squared is 112 plus 144 is 256. We're going to take the square root of that, and it's 16. So use Pythagorean theorem to get this 16. So we have S equals pi times r squared plus pi times r times l. So 144 pi plus 12 times 16 is 992 pi. So we just need to do 144 plus 192, and you get 336 pi square feet. And that's all you got to do for that section.